Which choice most effectively uses data from the table to complete the example? Okay, so I need to finish the example using data from the table. So it's kind of like a logically completes the text, quantitative with data though. So let's read it. Earth's atmosphere is bombarded by cosmic dust originating from several sources, short period comets, particles from the asteroids belts, Halley-type comets, and Oort cloud comets. Some of the dust's material vaporizes in the atmosphere in a process called ablation. And the faster the particle moves, the higher the rate of ablation. Astrophysicist Sanchez led a team that calculated average ablation rates for elements in the dust, such as iron and potassium, and showed that material in slower moving dust has a lower rate than the same material in faster moving dust. So for the same material, slower has a slower ablation rate. Okay. The table here is for ablation rates in cosmic dust. Okay. So the slower moving is the SPC and the AST. So for each element, it should be less, and it does. For iron, for example, it looks like it's less than it is for the faster moving elements. And check potassium, sodium as well. Okay, I think I know what's going on. Whereas the average ablation rate for iron from AC dust is 28%. The average rate for, okay, so they're saying the average for AST, which is a slower moving source of iron, is 28%. So whereas is what we're starting off with. So we need a contrasting example for that. Well, it would be HTC is 90 or OCC for iron is 98. One or the other or both would be our correct answer. So iron from SPC. SPC is another slow moving, so that's not what we want. Sodium, well, this is not iron, so that doesn't matter. We want the same element, but a faster moving comet. And that is C. HTC is 90%. It's a higher ablation rate for a faster moving comet. That is our answer. C. Okay. Which choice best describes data from the graph that support Taylor and colleagues' conclusion? So we have to know what they concluded and support that idea. So let's read this. Perovskite solar cells convert light into electricity more efficiently than earlier kinds of solar cells. Manufacturing advances have recently made them commercially attractive. One limitation of the cells, however, has to do with their electron transport layer, ETL, through which absorbed electrons must pass. Okay. Often the ETL is applied through a process called spin coating, but ETLs are fairly inefficient at converting input power to output power. Andre Taylor and colleagues tested a novel spray method for applying the ETL. The team produced ETLs of various thickness and concluded that spray coating holds promise for improving the power conversion efficiency of ETLs in perovskite solar cells. Okay, so what do we want? We want to show that spray coating, not spin coating, improved the efficiency. So what is our lead? Spray coating is the light bar, spin coating is the dark bar. We have a chart of power conversion efficiency. So my light bars should be higher. They're higher for the lowest performing and the highest performing. So regardless of what kind of original performance it was, the spray coating is better. So I think that's going to be our idea of just that. Both the ETL applied through spin coating and the ETL applied through spray coating showed a power conversion efficiency greater than 10% at their lowest performing. No, that's not the idea. I mean, that might be true according to the graph, but that is not answering our question. B, the lowest performing ETL applied through spray coating had a higher power conversion efficiency than the highest performing ETL through spin coating. Well, that might be. That just shows even the lowest spray coating, which is this one here, is higher than the highest spin coating, which just shows that spray coating is more efficient and therefore holds promise according to these authors. That looks like a good answer. Let's see what other options we have. The highest performing ETL applied through the spray coating showed a power conversion efficiency approximately 13%, while the highest performing ETL applied through spin coating showed a power conversion efficiency of approximately 11%. Well, no, that's just the highest performing to the highest performing. That's not a better answer. And let's just confirm that that is true. Yep. The highest performing is, I'm not even sure that's true, actually. The highest performing ETL through spray coating showed a power conversion of approximately 13%. That's not correct. The spray coating is the light bar. That's an efficiency of like 17%. So it looks like this is wrong according to the table. D, there was a substantial difference in power conversion efficiency between the lowest and highest performing. Yeah, there was, but that doesn't say any conclusion one way or another. So the correct answer to the question here is B. Okay, here we need to use the table to complete the statement or logically complete the text, which means we're going to be probably finding an answer that is not only correct according to the table or accurate, but also relevant, that answers the question. Mycorrhizal fungi in soil benefits many plants, substantially increasing the mass of some. A student conducted an experiment to illustrate this effect. The student chose 3 plant species for the experiment, including 2 that are mycorrhizal hosts, species known to benefit from the mycorrhizal fungi, and 1 non-mycorrhizal species, a species that doesn't benefit from and may be harmed by the mycorrhizal fungi. The student then grew several plants from each species, both in soil containing mycorrhizal fungal and in soil that had been treated to kill the mycorrhizal and other fungi. After several weeks, the students measured the plant's average mass and were surprised to discover that. So what did we learn? The effects of fungi on 3 species. We've got broccoli, marigold, corn, and 2 of them are mycorrhizal hosts, right? They benefit from the fungi. 1 is not a mycorrhizal host, so we would expect it won't benefit from the fungi. So here we have fungi versus non-fungi. That looks like our test. I should say this is the control group, and this is the test group to see how they react to the mycorrhizal fungi. And they are much higher mass for the corn and the marigold, which are hosts, and we would expect that to be the case. It's actually even higher for the non-mycorrhizal species that doesn't benefit from the fungi. So I guess that would be the surprising thing. That would be the surprising information. So let's look for that answer. Even the broccoli increased mass. Broccoli grown in soil containing mycorrhizal fungi had a slightly higher average mass than broccoli grown in soil that had been treated to kill fungi. Yes, they would have been surprised to find that out. Corn grown in soil containing mycorrhizal had a higher average mass than broccoli grown in, well, no, the corn to broccoli mass, there's no comparison there. That not surprise them. Marigolds grown in soil containing mycorrhizal had a much higher average mass than marigolds grown in soil. That would be expected, therefore not surprising. Corn had the highest average mass of all 3 species that had been treated to kill fungi, while marigolds had the lowest. No, that's just kind of telling us data. I'm not sure why that would be surprising. The surprise is that the broccoli also grew in mass.